Okay, today we're talking about a tiny, tiny piece of technology that has, and I mean this, completely changed how we see the world. It is a true unseen hero, and you interact with it from the second your alarm clock glows in the morning to the moment you hit the power button on your coffee maker.
Just think about that for a second. The remote you use to find something to watch. Those cool decorative lights you've got. The traffic signal that keeps your commute from being total chaos. And yeah, even the bright, beautiful screen you might be watching this on right now. They all share this one tiny secret ingredient. It is literally hiding in plain sight.
So, what is this little piece of magic? Well, in this explainer, we're going to pull back the curtain and reveal the simple, kind of brilliant tech that makes our modern world shine so bright.
At its very core, what it does is beautifully simple. It takes electricity and, with almost no waste, turns it directly into light. You don't have to heat up a fragile little wire. You don't have to excite any gas. Nope, it's just a pure, clean conversion of energy. And that right there, that's the secret to its success.
All right, first things first, let's finally unmask our unseen hero and find out exactly what it is.
And there it is. The technology we're talking about is the LED. It stands for Light Emitting Diode. Now, you've heard that name 1,000 times, but what does it actually mean?
Okay, let's get the textbook definition out of the way. An LED is a semiconductor diode that emits light when current flows through it. Now, that sounds super technical, right? But just think of a semiconductor as a special material that acts like a gatekeeper for electricity. And the key is, when we tell that gatekeeper to let the electricity flow, this particular material, well, it lights up.
So let's just forget all the jargon for a minute. It all comes down to that one basic function we talked about. It is a tiny machine built for one job and one job only, turning electrical energy into optical energy. It's a lean, mean, light-making machine.
So now that we know what it is, let's zoom way in and see what's actually going on inside one of these things. What makes an LED tick?
First off, this is not your grandma's light bulb. Forget about fragile glass and a tiny filament. LEDs are solid. They're built from these specially engineered crystals, semiconductor compounds, that are designed to do one thing really, really well: make light.
The absolute heart of the LED is this tiny little sandwich made of two different semiconductor materials. It's called a p-n junction, and it's where all the magic happens. This little core is then sealed up inside a clear plastic case, and that case isn't just for protection. Its main job is to be see-through, so all that awesome light it creates can actually get out into the world.
Okay, so we know what it is, we know what it's made of. But how does a solid piece of crystal actually create light? This is where the physics gets really, really cool.
The whole process works because of a principle with a fantastic name: electroluminescence. It's a big word, I know, but it just means electricity making light. That's it. It's the physical phenomenon that lets a semiconductor glow when you zap it with a little current. So how does that really work? Well, inside that semiconductor crystal, you've got these little particles called electrons just buzzing around. And you've also got something called holes, which are basically just empty electron-sized parking spots. When you apply electricity, you shove the electrons towards these empty spots, and when an electron finds a hole and falls into it, think of it like a high five. That connection releases a tiny burst of energy, and that burst of energy is a photon, a particle of light.
So this slide might look a little complicated, but it's really just the step-by-step of that hi-fi action. When you turn on the switch, you're basically opening a one-way street, forcing those electrons and those empty holes to run towards each other. They meet up in the middle, they recombine, and poof, a photon of light is born. And this happens over and over incredibly fast.
But wait, how do we get different colors? This is the genius part. It all depends on the type of crystal you use. Some materials have a small energy gap, meaning the electron doesn't have to fall very far to find a hole. That's a low energy high five, and our eyes see it as red light. Other materials have a much larger gap. So when the electron falls, it releases a ton of energy, and we see that as blue or violet light. By literally engineering the material, we can pick the exact color of light we want.
So now we have this amazing, super efficient, color-tunable light source. Which brings us to the big question. How did this little diode go from a lab experiment to completely conquering the entire world of light? Why did it win?
You know, the answer is pretty simple. They're just better. In pretty much every single way. They use way less power, they can last for years, even decades. They're tiny and tough, they're incredibly efficient, and they can turn on and off in an instant. It wasn't really a fair fight, it was a total knockout.
And that victory led to total domination. I mean, it started small, right? Think of that little red power light on your old stereo, or the invisible beam from the LED in your TV remote.
Then people got smart and started grouping them together. Millions of tiny red, green, and blue LEDs all working together to create the stunning, high-def screens on our phones, our TVs, and those massive billboards you see in big cities.
And from there, they moved into really critical jobs. Traffic lights switched to LEDs because they're so reliable and save a ton of energy. And car headlights got brighter, safer, and way more stylish.
But get this, it goes way beyond just lighting things up. Because they can switch on and off millions of times a second, LEDs are now used to send data as pulses of light through the fiber optic cables that power the internet.
So from a simple scientific principle to the very foundation of our modern visual world, the LED really is an incredible unseen hero. The amazing thing is how this tiny, simple device has had such a gigantic impact. It really makes you wonder, what's next? What new frontiers will this little speck of engineered light show us in the years to come?